I'm going to say that y is equal to x cubed. That would mean that dy by dx is equal to 3x squared. Now, that would also mean that 3 dy by dx plus y would be equal to 9x squared plus x cubed. This right here is what we call a differential equation. But it's not like the equation that we're used to, where you have x plus y equals 2 or 2a is equal to 3. No, these equations are equations that have a derivative in them, either dy by dx or some other form. So in our example here, we said that 3 dy by dx plus y is equal to 9x squared plus x cubed. The solution to this differential equation is this. Y is equal to x cubed. Why? We find the solution to a differential equation by finding the equation for which this is true in this equation. That is, if we're saying that 3 dy by dx plus y is equal to 9x squared plus x, the solution to this differential equation is y equal x cubed, because it is y equal x cubed that we differentiate, multiply it by 3, and add y to. That gives us 9x squared plus x cubed. Differential equations could be first order or second order or so on. A first order differential equation would be one that the highest derivative is merely dy by dx. That is, the highest derivative would be the first derivative in that equation. And we also have second order differential equations where the highest derivative in that equation would be d squared y by dx squared. That is the second derivative. So these are the most common ones, and these are the ones that you'd have to know for your CAPE examinations. If someone were to say to you, for example, that y is decreasing by 5 units every time x increases by 1 unit, then all that would be saying is that dy by dx would be equal to -5. In finding the solution to this first order differential equation, we are trying to find the answer to the question, what do I differentiate? What function do I differentiate and get -5? If we were to integrate both sides with respect to x, then the integral of dy by dx would have to be y, and that would be equal to the integral of -5. What's the integral of -5? -5x. That is if we integrate with respect to x. And we have our constant. So let's look at a few more examples. A very important type of first order differential equation is called variable separable. Now, if an equation is said to be variable separable, then that would mean that it's of some form where dy by dx may be equal to f of x, for example. So what do? We say, alright, we're going to leave the dy here and carry the dx over here. So in effect, it's like we're multiplying both sides by dx. And we just integrate both sides. So in effect, what's happening here is that we're integrating with respect to y here and integrating with respect to x here. So what happens here is that what happens at this point is that we're saying, okay, integrating 1 with respect to y, we get y. And if we're integrating f of x with respect to x, then that leaves us with the actual integral of x plus, or constant of integration. So let's look at an example of how variable separable is actually carried out. Or we have the differential equation dy by dx is equal to 2x plus 3. So what do? We say, alright, dy, the integral of that, is equal to the integral of 2x plus 3 with respect to x. So that would imply that y would be equal to what? X squared plus 3x plus c. And that is a solution to our differential equation. Another example could be where we have x squared dy by dx is equal to 4 minus x to the 4th. Now, before we try to find a solution to this, if you look back here, we have a constant of integration. There are times, though, when we are actually required to find what this constant of integration is. So to find the constant of integration, what would we use? Well, particularly in this example, as will be the case for all others, we are given two values of our variables x and y. We got that y is equal to 2 when x is equal to 1. So let's carry out our integration here. This is a variable separable problem. So what we would end up having the integral of dy being equal to 4 minus x to the fourth over x squared dx, and we're integrating that. So that, what does that leave us with? That leaves us with the integral of dy, or the integral with respect to y, being equal to the integral of 4x to the negative 2 minus x squared with respect to x. So what does that suggest? That suggests that y would be equal to negative 4 over x minus x cubed over 3 plus c. So our job now is to find out what this c is. What is this c that we're making reference to? What is the actual value of it? And we're going to be using these values here to figure that out. So x is equal to 1 and y is equal to 2. So substituting that would suggest that 2 would be equal to negative 4 minus 1 over 3 plus c. And let's just clear. So let's find the value of c. c would be equal to 6 and 1 over 3. So what does that suggest? That suggests to us that the particular solution of this differential equation is negative 4 over x minus x cubed over 3 plus 6 and 1/3. And you heard me a while ago refer to this as the particular solution. So where we keep our constant of integration, as was the case right here, that's referred to as our general solution. Our particular solution is found by using values that are given to us to find the actual particular value of our constant of integration. So a moment ago, we saw that there is a way to solve differential equations, first order differential equations of the form dy by dx is equal to f of x. Now we're adding something. It could be equal to f of x times g of y. In other words, it could be dy by dx is here equal to a function of x, the product of a function of x and a function of y. So what do we do to solve this? Our aim is to get all the x's on one side and all the y's on one side. So we're going to end up having 1 over g of y dy is equal to the integral of f of x with respect to x. So let's look at an example. Y dy by dx is equal to tan x plus 2 over cos squared x. So what do? We say, okay, the integral of y dy would be equal to the integral of tan x, and I hope you can see this, but we're going to be changing cos squared x to what? Sec squared x plus 2 sec squared x dx. What we're going to do from here is to integrate both sides, as you can see. But this side is simple to integrate. This side is a problem. So let's spend a bit of time on this side. How are we going to do that? We're going to say, okay, we're going to do a bit of substitution. So let's use the substitution for this part. So it would be that y squared over 2 coming from this would be equal to, we're going to be making our substitutions in this part of the expression. So we're going to have that this would be the integral of u du plus, we're going to be splitting this up now, 2 times the integral of sec squared x dx. Right? So what does that leave us with? Let's clear up right here. So we're going to have that y squared over 2 would be equal to, what's the integral of u? U squared over 2, but what is u? U is tan x, so that should be tan squared x all over 2 plus 2 times the integral of sec squared. What's the integral of sec squared? That would be tan x plus or constant of integration c. But then the thing is, we need to write this in terms of y, or we need to make the subject of this equation y, not y squared over 2. So let's write this in terms of y. So that would imply that y would be equal to the square root of tan squared x plus 4 tan x plus c. And this would be the solution to our differential equation.